James Curtis. I'm a soil scientist for the Natural Resource Conservation Service. And a while back, I think it was in 2012, we developed a soil study guide for the Envirothon. Are y'all familiar with this? Do y'all have a copy of this study guide? Does anybody have a copy of that?
No.
Okay. So what I'm gonna do is I'm gonna go over this study guide a little bit, and then when I'm over with, I'll see if I can send it out as an email to somebody for y'all to review, because it's a lot of material. We probably won't cover most of this today, but do we have anything in particular that y'all want to focus more time on, in particular with the Envirothon testing, or just you want me to just kind of skim this study guide? Okay. If at any time y'all think of something, just let me go and we'll skim over to the actual cater to y'all's training if y'all got something in particular y'all want to go over. Of course, this is when we developed this, we basically developed it based on the Canon Environmental website, you know, what they were wanting y'all to know. But I guess starting at the beginning, and this is just a PDF, you know, why is soil important? Well, it's important. Well, that's where we grow our food to eat on, but it also has some engineering ramifications when not properly planned out. This is a sinkhole and related karst topography with, you can see a collapsed building, you know, where the rain dissolved the karst below it, and then the soil collapsed, building collapsed. Urbanization is a big issue. And then here we got a big gully starting at the edge of a road over here with some erosion in there. So not properly managing soils can have environmental consequences to us and our neighboring landowners. And of course, part of the soil, you know, we got 5 soil forming factors, and we'll go over those later on. But one of them is the biology factor, and biology affects how the soil is able to produce a crop. That's, of course, this is just the farmable land that's worldwide. The green areas are the farmable lands. The red areas are non-farmable, and you know, it kind of goes down, green being the best. So it is basically saying it's a limited resource, so we want to protect it. And this is talking about how is the soil important. In particular, you know, it's important for you at your house. You know, if you got a septic tank, certain soils can be suitable for a septic tank. Sandier soils do not leach, do not filter the contaminants as well, so it's not suitable. And heavy clay soils kind of concentrate, doesn't allow any infiltration in the soil, so they're not suitable either. Okay. Functioning ecosystem. Okay, here's definitely one of your best questions, potentially, you know, is your soil formation and your horizonation. Your O horizon is basically organic material that is kind of like the duff layer in Mississippi, we generally do not have an O layer most of the time. If it is, it's going to be just a few, a fraction of an inch. With the exception of this would be these organic soils, these histosols. They call them, some people call it quaking soils, where you kind of can jump on the ground and it kind of vibrates. You're kind of being held up almost by a root mat. So that's, you basically could push an auger through without any resistance or penetrometer. Your A horizon is typically your surface horizon. It's typically darker in color. That dark color is due to the organic matter or the decomposing leaf litter in that particular soil. Some soils have an E horizon, which is alluviation. You're removing material out of it. So you've got an area where you're removing the organic matter and it's making it a lighter color. You're removing your iron oxides and even some clay material in there. Not all horizons have that. When we do look at that E horizon, we do not recognize a chroma 2 or less as being a wetness indicator in that E horizon. So if you happen to go out there and you see an E horizon, you get a chroma 2, that chroma 2 is not related to saturated conditions. Your B horizon is your accumulation layer. So that's where the clay and the iron oxides are accumulating. It's usually kind of brighter red. And your C is basically your parent material, or it's kind of a massive, doesn't have as much structure to it. And then if you're in some, say the northeast part of the state, you may have some rocks, and that'll be R is basically rock hard material type, bedrock type material. Oops. And this will be all available to you in a PDF. Again, your O horizon, is at your surface. In Mississippi, you're not typically going to have an O horizon, so you can ignore that. For the most part, it's going to be your A horizon is going to be at the surface, followed by potentially an E, but definitely a B most of the time, unless you're, got in a kind of a unique area. Let's see, and this basically goes over the definitions that I went over. O horizon is organic matter. It's basically no minerals in there. It's not any sand, silt, and clay is what I'm talking about is minerals. The A horizon is going to have your organic matter, but it's going to be mixed thoroughly with the topsoil. It's going to be darker in color. And then the E is your leached material. B is your accumulation of your iron oxide, gypsum, clays, calcium carbonate, and etc. And I guess before we get too far down the path, on the whoops, let's see if I can get this out of my way. But when you're studying this, you probably want to go to the DEQ website and look up the soil land use on-site learning objectives, and scroll down to those. And that's what you want to focus on, on your studying. So we went over 2 so far. We hadn't covered number 1 yet, and we'll eventually get to it. So potentially, you might want to skim this first to see what you really need to study out of there. Let's see. Let's go back to this. Of course, those are some example profiles. You see, we've still got a red color in this one. This isn't, but the darker color of red is due to organic matter. The red color in this soil and in most soils, and the brown color, is due to iron oxides. And if you have got some gray color, say like here, that can be iron oxides, but it's going to be in the reduced state, waterlogged lack of oxygen. The inherent color of soils is gray, and the reduced form of iron is clear. So it shows you the true color of the soil. If it's oxidized, think about say a piece of metal you throw out in the yard that may rust. Rust is oxidized iron, and that's what you're seeing in these soil profiles, making that red color. Let's see. I guess another potential test question is what's the 4 components of a soil, and that's the air, water, mineral matter, and organic matter. And the relative abundance influences the behavior of the soil. Ideally, you would want half your area to be pore space, which would constitute your air and your water portion of the profile. That's the ideal conditions. Let's see what we got here. Yeah, this one here is we got the soil and water. It's at 50%. That's ideal conditions. If you observe an area that had a lot of traffic in it, say a farm road, for instance, dirt farm road, it's going to have a lower concentration or percentage of pore space or soil and water space. So it'll be less available water, less available infiltration. So that's mineral part might be 60% instead of 45%, and so forth. Weathering is just a decomposition of rocks and minerals to basically make soil. You got basically 2 broad categories of weathering. You got physical weathering, which is related to temperature, heating and cooling, and water and ice interaction, with kind of when ice freezes, it swells and pushes open rock, breaks it up. And wind, for instance, when you got wind pushing sand, you got sort of a sandblasting effect. Then you got plants and animals that break down the original parent material. The other type of weathering is chemical weathering, and it's more pronounced in hot weather, but it can be in the form of acid rain coming down, kind of melting or dissolving, the rocks and turning it into soil. Of course, this is some processes of the chemical weathering. Parent material. Parent material is basically where your soil come from. And here in Mississippi, you know, we've got basically two forms of apparent material. One of them being the coastal plain marine sediments, and the other being alluvial sediments. And I guess the third one would be some windblown areas in the middle part of the state. Let me see if I can find a map on that real quick. I thought I had one pulled up. Let's see. I might have one here. Here. Let's see if I can pull this up. But when we're out here mapping, you know, let me see if I can zoom this down. Looking over here, this is where most of our cropland is. This is Mississippi alluvium, and alluvium is river-laid, water-laid sediments. So you got the Mississippi River down here, and this is the historical floodplain of the Mississippi River, this kind of purple color. And these sediments are coming up from, you know, way up north. A lot of them are glacial till sediments. They basically, whatever the Mississippi River picks up, it drops it out during massive floods. Today, you know, we kind of protect the flooding with a levee system going down, protecting the cropland and such from these floods. But at one time, you know, there was meandering streams going all throughout here, and it was a lot more flood intensity in this area. Of course, this area was historically hardwood timber. It was cleared and converted mostly to cropland right now. This next orange layer is actually windblown material. This is what we call loess. Loess is basically high silt material. So almost all the soils in this area are silt loam and silty clay loam textures within this area. It's one of the most consistent areas in terms of texture for the whole state. And that's because wind can separate these particle sizes so much better than just about any other laid, depositing sequence. And then the rest of the state is a coastal plain marine deposited sediments. These down here mostly have a sandy loam surface, and they can, with depth, say 10 inches or so, they can be sandy loam to clay. This one area right here, almost all of it is heavy clay, high strength swell soils, silty clay loams, clays. This is where you have a lot of problems with your foundations of your house. You know, this is, some people call them Yazoo clay, but it's basically high smectitic clays. And these high strength swell clays can break your foundation. And bottom line is, you get to some of these houses, you can't open the doors in them. You know, they start dragging. You've got cracks in your bricks. You've got a lot of road damage as well down this I-20 corridor, starting about Morton, going all the way to Newton. You may have noticed that they dug out the entire highway down that way in Scott County because they were having to fix the soils. It was kind of looping up and down. So they dug all that out and put some material in there that didn't shrink and swell as much. And that shrinking and swelling is due to your water. So when you add water, it swells. When you take water away, it shrinks, and you'll see cracks. You know, sometimes cracks all the way to the surface. And then this is some of your northern coastal plain up here too. And we got a kind of a clay belt coming in here as well. Let's go back to this study guide. And a lot of this stuff, you know, you can go over on your own, but you know, residual is just formed in place. Most of the stuff is transported in by in Mississippi would be the alluvial and alluvial floodplains, river systems, and of course we do got some wind, which is Aeolian, which is I called it LUS. For the testing, they may call it Aeolian. And then let's see. Oh yeah, the oceans. So most of the state is marine deposits. And then that one belt going north to south and near the Mississippi River line, you know, floodplain line is that Aeolian. And then you got organic, which is those peat bogs or histosols. It's in narrow bands, kind of the floodplains, normally down kind of in South Mississippi. This is the MLRA map, which is similar to the one I showed you. It shows you the Mississippi River floodplain right here, number 8. Number 7 is coastal plain sediments. But realistically, right in Mississippi, right on this boundary right here, we've got some LUS. So we call it silty uplands sometimes, but that's that Aeolian deposit that's not identified on this particular map here. Okay. Climate. Let's go back over this thing and make sure. Here, I think I didn't cover this well right here. You know, we have 5 soil forming factors, and that's typically a test question. Parent material is one of them. Climate is another one. Biota, which is just living organisms and vegetation. Topography is one, which is your slope, your aspect, your landscape position, and then time. Some people call topography relief, but climate, you know, the main focus on the climate is, you know, the amount of rainfall you're getting. So if you got more rainfall, you got more leaching, more movement. So that's one of the biggest factors with the climate is your water and your precipitation amounts. Here in Mississippi, you know, we're getting upwards of 60 inches of rainfall a year. Up north, you might be getting 15 inches of rainfall a year. Temperature is another one. It's got some interesting facts in here. Every 10 degrees rise in temperature, you double your biological and chemical reactions. Yeah, it's also related to freeze thaw. Influences the type of vegetation. You know, here in Mississippi, one thing, our I-20 line is kind of the rough line for longleaf pine. So south of I-20 is more suitable for longleaf pine. Shortleaf pine is more suitable north of I-20. You know, that's just one example. Biota, one of the things that's most influential in the soil is what you don't see in the soil, the microorganisms, and even some of the macroorganisms like earthworms and such is very important. But the focus here recently is improving the fungi and bacteria, the microorganisms in the soil. This is an example of a prairie system that's on a kind of a Maytag soil series in Scott County versus a forest land. And you can see right here on a prairie system or a grass system, you're able to see more organic matter and a deeper A horizon typically on a grassland situation versus a forest land situation. You see the narrow A horizon right here on the forest land in a pine stand versus a thick horizon or more organic matter in the grassland system. This is mostly due to the part that in grasses you have a lot of biomass in forms of roots, fine roots that break down fairly easily and pump a lot of organic matter or organic carbon in the soil. So you had a question of what's the best carbon sink, a grassland or a forest land. This scenario kind of would lead you to thinking a grassland would be capture more organic carbon than a forest land in a lot of situations. Yeah, this is effects of animals. I think most of that you can just read up on, but it's basically, you know, a lot of these animals are boring holes like earthworms, and that's increasing your permeability of water, you're decreasing your bulk density, the ease for the roots to go through the soil, as well as breaking down some of the materials and making it more available for the plants. And the topography is the last one. Of course, they call it relief here. And it's basically your slope and your slope aspect of the landscape. And when a lot of people, I guess you may not know what slope is, but slope is basically how steep something is. So slope is usually in a percentage, and it's the relative fall or rise over 100-foot length. So if it drops 2 feet over 100-foot distance, that's a 2% slope. If it drops 20 feet in a 100-foot distance, that's 20% slope. And of course, you don't have to do your measurements in a 100-foot distance, but it's just easier doing the math. We typically do our slope measurements in the field with a clinometer, and it's basically just a tool that you look through in order to get it actually give you the degrees and your percent slope. We can also measure tree heights and other stuff with it as well, but that won't be part of your testing. Landscape position is one of the major things we look at when mapping a soil. You know, if you I guess your landscape position, you got certain soils that are going to be on this ridge top right here versus the side slope. The side slope's, you know, typically going to be a lot steeper. And then your bottomland or your floodplain units, you know, coming, you know, is typically flat. And you got sediment coming from upstream deposited here. So whatever's in that floodplain is representative of what's upstream what's been eroded. One step above the floodplain is a terrace position. So you got a floodplain or recent alluvium, you got a terrace, side slope, and then a ridge top, basically is what we're looking at. Soils on the ridge top are typically more developed. So they may have in this particular one, this one has an A, B, and C. In Mississippi, would probably have an A, E, B, and then a C down deep. In the floodplain, you may just have a couple of A horizons and then a C horizon. You probably wouldn't have any E's for sure in that landscape position. In the terrace, you typically have an A and a B horizon as well, but you often don't have the E horizon, and your C horizon comes up a lot quicker for the most part. Let's see here. Of course, this is another model here. They got summit. I was calling it a ridge top. You got a shoulder, back slope, toe slope. I was calling the shoulder slope to the back slope to the toe slope I was just calling it side slope. So you could break it out even more. And then down to your floodplain. And this particular one didn't show a terrace, which is one step above your floodplain, and it's going to be flat as well. You know, or close to be, it's going to be a lot flatter than your toe slope and side slope. It's typically A and B slope terraces are, which is 0 to 2 is A slope, 2 to 5 is B slope. This is slope aspect. So that's basically which direction the slope is facing. In Mississippi, it almost has no effect. But up north and in mountainous conditions, mainly in mountainous conditions, your north facing slopes are always cooler and moisture and have more moisture and have totally different vegetation as compared to the south facing slope, which are warmer and drier. So if you're in the mountains, sometimes you'll notice, that on the south facing slope, it'll be a lot more droughty and it may not be able to sustain the trees like on the north facing slope. Time, and that's just how long it's been there. So more time to weather, more time to leach out.
Hey, James, we have about 5 minutes left.
Okay. Well, let me skim out. Here's a color book. The main thing we want to do is you able to identify soil color. And when we're identifying soil color, you must moisten the color. Far as wetness, if it's chroma 2, this bottom row is chroma. So chroma 1s and chroma 2s indicate wetness. So if it's got a chroma 2 in it, it's potentially be wetness. If it's a higher color, it indicates a little drier. So further to the right, typically more dry. But it's just one line going here. Of course, we got to look at moisture on there. For instance, this is, see this spot right here? This is after you wet it. See, it's the same color throughout this profile, but when you wet it, it changes the color a few spots. So that color went from a a lighter color, which is way up here on the screen, to way down here. So all your colors want to be moist colors. And we're looking at the color of the whole matrix and the color of these finer particles, you know, so you say less than 1% would be this lighter color stuff, but the matrix color is this. Let's see, but this study guide is what's going to help you out. You know, it talks about permeability and it's related to the soil structure. Of course, we've been talking about particle size a little bit, but you know, sand, this is a blown up picture. You know, it's sand like in a beach. It's real small. This one's blown up thousands of times. Clay is actually microscopic, and silt is a little bit bigger than that. Silt is real smooth when you texture it. I think what I want to do is, since we don't have but 5 minutes, is I want to give y'all some more information. And this is a pretty good, it's got some pretty good videos on here. And I would recommend y'all looking at some of them. And like this one here in particular, you know, soil texture we were talking about. But you know, you can go over that, but you got to wet it and then rub it to your hand. But anyway, that's I'm gonna forward some of that to who do I need to give this so y'all can have some links to some data where y'all can study on your own a little bit, since kind of ran out of time. Do I need to just give it to Chelsea and let her disseminate it, or what would be the best thing?
Hey, James, this is Chelsea. You can just email them to me, and then I'll email it out to the advisors.
All right. And like I say, main thing is that study guide, and y'all can add, feel free to contact Chelsea, and Chelsea will give me my my contact information so I can reply back to you. But I was just going to send out some of these resources for y'all. Y'all got any questions in particular? I kind of like this other book too. This From the Surface Down is a pretty good resource that kind of goes over the basics of soil and soil survey. How much time we got left?
2 minutes.
2 minutes?
Uh-huh.
I don't think it's no need to go any further. Like I say, this book is 84 pages. And ideally, you know, on this left side of the page, you know, you got your chroma here and your value here. As you go up, it gets lighter colored. Everything 2 or less is considered moist. You always start out the terroir page. If it's yellower, you go toward the back of the book. If it's redder, you go toward the front of the book. And if you say it's a 10YR 82, you go over here and you can see the name of the color. And I think it says very pale brown, you know, but that might be something they ask you type thing is what color is the soil A horizon? And you have to give the Munsell color of 10YR 3. And then you may have to say, well, 10YR 3 is a whatever brown that is. I'd have to zoom in and see, but dark brown. Anyway, that's how you get your color out of it. Like I say, I didn't do it justice going over everything, but I think you'll be beneficial to review this, this study guide. And it was catered to what we were doing in Envirothon back in 2013. So I think it's got a little more objectives than what the current objectives are, but this ought to be a valuable resource for you, and I'll send that out to you. But that's all I've got. Main thing is I just wanted to cover most of this book that I could. I don't see anything that really stands out, you know. You know, a hydric indicator is basically could be a gray color for the most part, but it could be red color, you know, around is what we call redox. Could be accumulations of iron and reductions of iron. And it's all within the upper, say 10 or 12 inches, you know, with wetland hydric indicators. Soil drainage, you know, is a little bit deeper than that. So it may be the upper 2 feet or so. You may have a 50% gray color, that'd be poorly drained. If you got a gray color coming in within 24 inches, but it's less than 50%, that may be somewhat poorly drained. You got gray colors coming in deeper than 24 inches and before 30 or 40, before 40 inches, that would be moderately well drained. And then if you don't have any gray colors within 40 inches, that'd be a well drained soil. But that's one thing that's not spelled out too good in this book, but it's kind of well drained is kind of not much evidence of moisture, no chroma 2s. Poorly drained is 50% grays near the surface. And then somewhat poorly is, you know, you've got a, you know, somewhere in between. But I can open it up for questions and I guess that's probably all the time I have.
Okay, do we have any
Land capability classes is real important also.
I don't guess we have any questions for you.
All right, well, that'll work. I appreciate y'all's time, and like I say, I'll send you out this information. This study guide's probably going to be the most beneficial to you.
Okay.
And then a few videos related to the y'all's on-site texturing and color ID. You know, when you're in that pit, you're going to have to identify the color, the horizon, the color, texture, horizon, and the structure of the soils is the main thing that's going to be covered in those pit samples. And I'll send out the information related to that. I'm sorry I couldn't be there in person, but I hope this helps y'all out.
Thank you.
You're welcome.